Hey everybody, how are you doing? My name is William Paul Liggett from Junk Text, and today I'm going to be teaching you about SQL multi-table queries. Okay, so what does that mean? Well, SQL, hopefully you know by now, stands for the structured query language. Now, that is the standard language to talk to databases. You can do all sorts of things with SQL. And so today with SQL multi-table queries, well, that's what we're going to do. We're going to talk to multiple tables to basically query or ask a question that can be very powerful when you basically effectively recombine the tables again to make sense of your data. And you can do all sorts of things. For instance, there's a buzzword that you hear such as data analysis, all right? What is data analysis? Well, actually, one of the original ways you could use data analysis, which has been around since the 1970s or so, is SQL. You have data, and it's all sorts of stuff that might be about your company, whatever, your organization, and you're basically trying to find things that just don't jump out at you right away, or that might take a while if you were just using spreadsheets and so forth. So let's get into it. All right. Actually, before we do, you know me. All right. I got to give you one joke in here. All right. Okay. What do you call an alligator in a vest? An investigator. You love it too. All right. Okay, let's get into it.
All right, so when I was talking about that we're going to cover these SQL multi-table queries. Now, before I begin too far, what I will say is I'm currently in the process of getting my other lecture series on YouTube. So this lecture that I'm going to go into is actually more of an advanced topic. So it's not necessarily the best starting point with trying to understand what's referred to as relational database technology, or even SQL for that matter. This is somewhat more advanced. Okay, so if you're watching this video and you don't see any other videos out there right now, I'm working on the process right now to get them all out there. I'm trying as fast as I can to get them up and running online. But anyhow, if you just want to still expose yourself, nonetheless, so dealing with this subject of multi-table queries, like I was saying, is if you take the idea, like those three words, a multi-table query, it's basically self-explaining what you're doing, okay? You're talking to multiple tables, okay, because remember, databases, they like the lingo of tables, and which is kind of, they look like spreadsheets, but they're not. You don't want to say a spreadsheet. And what you want to happen is these tables often have, they're often basically connected to each other in some fashion, and they're basically meant to be put back together. Okay, but the reason why you break them down into these many tables is to help ensure that you don't have redundant data that could potentially have aspects of introducing typos or something like that. So it gets kind of out of whack if you keep one basically massive database table for everything. It's just too hard to maintain. So when you're dealing with databases, it's the art of trying to break things down into many tables. But then, because you did that, you then have to get into this territory when you want to use SQL, which is just like, it's just computer code basically. It's not a programming language outright. It could be if you're dealing with more advanced SQL things. It's referred to as SQL/PSM, but that's not what I'm talking about here. That in this regard, we're trying to basically talk to our database to ask it questions. All right, and you're going to see the practicality of how this plays out in this video. Okay. And pardon me for a sec, just drinking some water. Okay, so the thing you definitely need to keep in mind when you're dealing with these multi-table queries in SQL, as you can see from my slide here, it's talking that you need two major things that you should really worry about. Okay, first of all, it sounds pretty obvious, but you need to identify which tables you need in your SQL syntax. Then the second thing, though, which is very important, is you need to be able to connect these tables in a logical manner. Now, you may be wondering, well, what does that mean, a logical manner? That's where, again, we get into this, why there's this very big importance of database design. And, you know, one of my favorite topics is the entity relationship diagram, which is a model. It's basically a picture that's you're summarizing of what your database, like of how it's connected. It's basically the blueprint of your database system, okay, of your of what you're dealing with. And so you're going to see how this plays out with this. As you can see highlighted there, it's talking about this primary key to foreign key relationship. You need to do this properly, or else what can happen is, say you're doing this SQL multi-table query and you think you got it down, and you run the query, and the database gives you back some sort of information. The thing is, you may want to just double, probably triple check to make sure that what has been returned back to you actually makes sense. Like, you want to double check that any information that your query gives back to you, is that actually valid, okay? And where it can get off base is if you don't have this primary key to foreign key relationship kind of baked into your SQL syntax, okay? So I'll show a practical example of how this works. Now, the flow of this video lecture that I'm going to go into is you're going to see about, I don't know, 6 or 7 slides, and I'm going to give you the idea of what I'm talking about. Then what we're going to do is I'm actually going to run queries. I'm going to type this stuff in there, and you're going to see how this all kind of shapes together. Okay? All right, so here we go. All right, so in this slide, what I'm talking about is I have a very small car dealership company. You know, basically somebody who sells cars. All right. Now, they don't have too much going on, and they just wanted some easy way but consistent way to track basically which cars that they sell, like which car manufacturer, which is also known as a make, such as like Ford, and which models that this car dealership maintains. Okay, so like a Ford Fusion. Okay, so that's a thing when talking about this make and model. It's more of it's like car terminology. You have a make, which is like the vendor or the manufacturer. They make cars. So like Ford, Chevy, Honda could be the make of a car. And if you look over here, if you see my mouse, I have this thing of make ID. Now, what I'm saying in this reference down here is this is just a small car dealership. We're not using like VIN numbers or things like that. We're not using like official model numbers. This is their own little internal model and make ID thing, all right? And what's going on here is the make ID, this is going to be useful in mainly for a primary key. It's so that you can have each row to be unique and so forth, and such. Now, we have it broken down into 2 tables because, as I just mentioned, this is a good way to design your database because we don't, for instance, have to say repeat the name, say Ford, over here twice. Notice how there's make ID 1 is for Ford. On this other table here, the model table, it says these 2 cars, there's a Ford, that's what it's saying, make ID, so then that means that's a Ford. So a Ford Fusion And then they have this internal made-up model ID number of 100. Okay. Then likewise, there's the Ford Escape, and they then just came up with model ID number 101. Okay. So again, these are just kind of made-up internal IDs, just to be something simple. All right. Now, I'm just orienting you to this kind of database, this small little database. So to be clear, there's two tables, make and model, and we want to combine them back in there to just ask it some questions here and there. All right. So with that being said, let me show you what I'm getting at. So, sorry, just need a little more water. As you can see, this question that I have, like, how can we create a report to show us all of the cars? It sounds simple, right? We just want to combine the stuff so that, like, if you see down here, we want to see that, oh, currently we are selling the Ford Fusion and the Ford Escape and so on, right? Well, one of the things, if you're familiar with some basic SQL, is you might get tempted to you could do like that select all, where it's like select star, and then like from these two tables. Okay, so I'm going to show you this. All right, so I'm going to go to the next slide here. Now this is what I'm saying is, do not do this. Okay, this is very tempting. A lot of people make this mistake and they think this seems fine because they will get information back. The problem is, it is actually bad information. All right, so what I'm saying is, this is just screenshots of the same make and model. There's nothing new to you to look at on the tables. All right, it's just to refresh your memory of what you're looking at of the data. Now this is the actual SQL that I'm talking about that you should not do in this regard, because we're talking to two tables. If you're only talking to one table, this syntax might be okay. All right, because what this syntax is saying is you want to select, which means grab. Okay, basically, so you select all columns, okay, from these two tables. All right, you're like, yeah, that sounds great. We want to combine all of everything together. That sounds great. No, again, this is terrible. Don't do this, because watch what will happen. You're going to get this return back to you. Okay. So look at what you're dealing with. And now on the right hand side, I'm explaining why this is bad. All right. But notice even the title of my slide, I'm like, oh, so Ford, Chevy, and Honda, they all sell the same model names. So look at the data or the information that it's given back to you. That it's saying that, well, we have a Ford Fusion. Okay, that sounds good. That's why it's in green over here. Ford does sell a model called Fusion. That sounds reasonable. But then look at this. We got a Chevy Fusion and a Honda Fusion. I don't know about that, right? So just to be clear, Chevy does not sell a car called the Chevy Fusion. It just does not exist because they don't want to compete with Ford. Like the name of it, there's trademark issues and such. So Honda is the same thing. They don't have a Honda Fusion. This is bad information, is what we just did. Okay. And so forth. Okay, so then we got the Ford Escape, Chevy Escape, Honda Escape, and then see down here it flips. Now Chevy Impala is good, but this, so you don't even know what to make sense of this. It seemed like you got something that works, but unfortunately that is not the situation. All right. Instead, look at the tables really closely. Now I had to chop this table down slightly just to make it kind of fit because of this line here. But we have make and model. All right. Now you remember, when you have your two tables broken down like this, you need to connect them properly, or as I stated before, they should be connected logically. Okay. So notice how there's this column on this table make, where it's called make ID. Well, look closely at this table on model. There's a column called make ID, as we touched on a little bit before. Okay? So what this is suggesting, if you're familiar with relational database design, is that, oh, I'm pretty sure that the model table, okay, has a foreign key of make ID that is referencing this table over here, which in this case is the primary key in this table. So let me say that again. The make ID in the model table, this is the foreign key because it's referencing a primary key in another table, which is the make underscore ID column over here. Okay. Now, yes, model has this. This would be the primary key because it can uniquely identify each row. It's numeric. It's short. Sounds good. We don't really care as much about that. A primary key does two things. Just to highlight the point when you've been learning about primary keys and foreign keys and you get kind of confused. So a primary key serves two aspects. Maybe this is a good example if you just look at this model table. Well, in this regard, the model ID, this would be a good primary key for this table because a primary key is helping to keep each row unique, all right? And that's, you need that so that when you are doing what we're trying to do here is that we want to connect two tables to where they make sense, all right? So when you do that, that's where you get that that idea of over here, which is a foreign key. Okay, so we have make ID is referencing over here as the primary key, all right? Now, you need to understand this so that when you're writing your SQL code, this is how you should write it. Now, if you're looking at it really closely, you'll notice that these first two lines here are exactly the same as what I showed you previously. We have select star, okay, or asterisk. Select all columns from both tables is what we're trying to say. Select all columns, every single column here, like all of make ID, make name, model ID, model name, and even this thing, I guess. That, and we're saying, but only combine the rows and so forth where we have this. Notice I'm talking about this join condition, that you have you're talking about your primary key to foreign key relationship. All right, is I'm saying where make underscore ID equals model dot make ID. All right, so, and it doesn't really matter how you write this. Like these, you could flip this around where it's like model dot make ID and make is on this side. It doesn't really matter because this is an equal sign. It's equal to. I tend to write my syntax when I'm writing just because it's easier to look at. I'll actually refer to the diagram, the ERD, the entity relationship diagram, and I'll just write it basically like left to right or top to bottom. Something that I can just, what I'm doing is following like a chain, like a map, like, oh, start from the left-hand side, go to the right-hand side. And it's just easier flow-wise for me, okay? So that's basically the gist. So if you wrote your syntax, and if you have these are two separate tables, watch what's going to happen. Is like what I'm saying is on the next slide, we're going to see the result of this SQL. All right, here we go. So here we have, this is all of the rows. There's not any more rows that I have in this regard. Okay, is the, first of all, there's a lot less. Okay, so I'm going to skip back. I'll show you the bad tables join. Here, there's a bunch of things. We got 21 in, this is Microsoft Access, all right? There's 21 of these rows, which they also like to say, instead of row, they'll say a record, all right? But there really shouldn't be 21. We don't sell 21 different cars, like models and stuff. We actually only sell, we can count it, 1, 2, 3, 4, 5, 6, 7, all right? Because We have, ignore these make and model numbers. We have the Ford Fusion, Ford Escape, Chevy Impala, Chevy Tahoe, Chevy Volt, Honda Civic, and the Honda CR-V. Now, again, this is just for some made-up car dealership, small little company that I created, just to kind of, so you can see something in action, all right? In this case, what we're doing is, this is referred to as, we have properly joined the tables. You're going to hear this join, okay? Now, the syntax that I showed you, there's different ways, I just press my back button here, is that in this regard, I'm doing, this is referred to as an inner join, okay? You're going to explain, you'll understand another idea later. I'll get into a bit with outer joins. But this is my preferred syntax when I do inner joins because it's just a lot simpler. There is another way to write this. They do the same thing, all right? There's really no difference. I just argue this is the easiest way to kind of write a multi-table SQL query, and you only want to just like put everything where everything makes sense, all right? So with that in mind, so again, here's the proper table. This is what we want because it's based on this primary key to foreign key relationship. So this is actually good information now, and that's why if you look really closely, I named this little query as good simple join, all right? Okay, so here let's keep going. All right, now let's make this a little more interesting. It looks a little bit more complex, but don't be scared, okay? I'm basically doing the same process. I'm just trying to kind of filter down the data. Like, say, for instance, some car dealership manager or something like that is like, oh, what did we use again for that Chevy Volt model number? Like, I forget. Like, say they're using some sort of a system and they're not like database SQL people or something like that. So they kind of create this ahead of time. They can, or they ask their database person or something. Regardless of the reality, like, this is how you write the code, the SQL to make this happen. Okay, so the end result, look at this, is it looks really simple. We got one row that we see. That's it. That's all we wanted to see. We wanted to see the Chevy Volt and the model ID number. That's all we wanted to see. Okay, so we're doing, let me back up a little bit. We're doing the same thing as basically this. It's just the star, this asterisk thing is kind of not always the best thing to use unless you have a really good reason. This is just like a quick and dirty thing to do. The preferred way of writing when you write SQL is to really never use this asterisk thing unless you're just quickly just pulling up data, okay? Oftentimes, you want to be very choosy of which rows you actually see, okay? So in this case, we only want to see the make, model name, and then the internal model number thing here. So with that being the case, that's why my first line of the code says select make name, which matches here, make name here, model name, which is here, okay, and then the model ID. And this is how you write it. Now, this is my preferred way of writing SQL syntax. Other people have gotten into this, I argue, terrible habit of making everything either all lowercase, like all this syntax stuff, or all uppercase. I think that's a bad habit, honestly, because for me, I am, by trade, I'm more of a software engineer. So I might be writing Java code, and then there's a bunch of Java code that I have, which is all like lowercase. Then here and there, I need to talk to some database. Okay, so when I have some SQL code sprinkled into my Java program, I don't want to be confused to think like, am I looking at Java code now? I don't know. Furthermore, so that's why I have here. So I have select from where, all this other kind of stuff. This is actually SQL syntax. All this other thing is just what I called things in my database. All right. So I'm making it very clear to me in this code of what is what. I don't get confused of what I'm even referencing here. This is just a good pro tip, basically, that people really should start adopting. It's kind of annoying. I've worked on projects where there's lots and lots of code, like a PHP project or something like that. Everything's all lowercase in the PHP code, and then I run into some SQL stuff, and then this is all, I'm like, what is this PHP code? Or it's just, trust me, you're going to save your sanity later on if you adopt my kind of convention here. Anyhow, I'm going to keep moving on. So with that in mind, the way you write this, I'm going to just repeat this. We have select. We're going to select which columns we want to see. So the make name, comma, model, underscore, comma, and then model ID. There is not a comma here. Do not do that. If you do that, especially in Microsoft Access, okay, that I'm using, it will actually not work. It will no, what are you talking about? Do not put a comma here, okay? Then, you don't have to, but I put this on another line here. So then I'm asking from, which tables we want to pull data from. So in this case, we're talking about the make and model table. But the way you write that is make, comma, model. Now, per my convention, I argue it's good to have this as title case. So capital M. And so anyways, you can see it. Moving on. Then in this sense, this is the same thing that you saw before. This is our join condition. Okay, we want to connect the tables together where it actually makes sense. All right, so where make ID is equal to the model dot make ID, so forth, which I just explained. Sounds great, but we didn't want to stop there. We're like, okay, that's great. We are able to connect, join our tables together, but we only care about seeing the Chevy Volt. Oh, okay. So you have to then put that in there. So that's why that's these are conditions that we're putting on here. So it's oh, and the make name should only be Chevy. Okay. And this is a single quotes. SQL syntax prefers single quote characters. All right. So just get into that habit. Then it's okay, we don't want all Chevy vehicles. We only want to see the Chevy Volt. So that's why it says another and here. There's no comma here. I just put this on another line and kind of space this 4 spaces. That's kind of 4 spaces. And that's why it looks like this. And the model name is equal to the Chevy Volt. Don't forget your semicolon here. Okay. Get into that hat. Make sure that the very end part of your SQL syntax has the semicolon. All right. If you ran basically code against this query on this database, this simple car dealership, you will get this result. And I think, let's see here. That is, oh yes, that is my last slide that I have. Okay. Okay, so that's the overall idea of what we're dealing with. Okay. Now let me kind of show you in more real time of how this works out. All right. Okay. So in here, this is, so for my my college students and so forth, I actually have them starting out with Microsoft Access. Even though I'm an open source advocate, Microsoft is not open source. It's the easiest kind of program to kind of get accustomed to database technologies. It's actually pretty powerful, and so forth. I eventually have my students in also my later video lectures that we get into MySQL, which is a great database system, which is open source. But anyhow, using Microsoft Access, I'm going to show you how to do multi-table queries. But before I just start throwing a bunch of syntax around, I want to kind of orient you to the database that I have kind of built up here. So in this case, there's actually 5, let's see, 1, 2, 3, 4, 5, yeah, 5 tables that I have. I'm going to show you just in a minute though where my entity relationship diagram, there's actually only going to be 4 tables. It's because later on in other videos I connect this other hours work table in there, and so forth. So this basically what you're looking at is on this section here. This is my data. So for instance, if I say open up absences, you can see a bunch of data in here, da 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 da, and so forth. This is like representing when an employee might be absent. Okay. Or say we have employees here. Okay. So this is just like, which employees do we have? How much money do they make? When were they born? What's their employee ID number? Things like that. Okay. But then it's like, okay, and then we have over here, this benefits table is like, the way this design works is each employee kind of negotiates their own little health, their little benefits plan and stuff. So it's very customizable. So not everybody necessarily has a health plan. They may or may not. Their life insurance can kind of bounce around and so forth. So that's kind of the gist. But you'll notice that even in this benefits section, it says the employee ID of, say, 1001 has a health plan, dental plan, and so forth. But it's like, well, who is employee ID 1001? Well, that's not clear, because you'd have to basically go back into your employees table and like, who's 1001? And you're like, oh, Kate Navarro. Okay. So that's the whole overall point. We're going to, in these SQL queries, we're going to combine these tables so that we don't have to like open up manually two tables like I just did there. If we're just looking at, say, we want to figure out which employees have health plans, and I want to know these employees' names. All right. And say you don't care about if they have life insurance and such. You just like, hey, who has a health plan? Okay. So that's a practicality, stuff like that the an SQL multi-table query can help you kind of understand. All right. So I'm going to close this down. Now I'm going to show you my relationships of all of these tables. So using Microsoft Access, how you get to there is you go to Database Tools, then you go to this thing where it's Relationships. Now in here, I've already connected everything. Everything is 100% great with all of my data in the tables, and it's 100% great. So, and we can see that because I have like these little symbols. I don't know if you can make this out completely from if you're on your resolution of where you may be watching this video. The main gist is there's actually little symbols on top of these lines that are connecting these tables. So like for instance, this is the employees table, like who our employees are, and say their benefits. Okay. So when you see these little symbols though, like over here, 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 it means that it has referential integrity, such that like, say I create something over in the benefits table for employee number 99999, and it's like, well, there is no employee number 99999. All right, so that's where these little symbols would jump out and give me basically an error message saying like, no, what are you talking about? That person doesn't exist. In that case, that kind of error message would actually be a good error message, because it's protecting our database system. It's ensuring that we don't have just free-form nonsense in our system. All right, so that's one of the beauties of a relational database. It has rules, and you need to follow these rules. And these rules are often built for a good reason. Then, though, like again, we're going to get into the SQL queries. All right. So one of the first aspects, like I talked to you about, is say we're curious about does an employee or which employees have health plans, right? So in that regard, what I'm going to do is I'm going to create what's referred to as a query. You might be seeing over on my left-hand side, I got a bunch of pre-built queries going on. These ones are all dealing with basically a single table, like I'm just asking questions on, say, the employees table or something like that. So now we're going to use 2 or more tables. It could be 3 tables, 4 tables, whatever, to ask questions. We want to get some information, basically. So I'm just going to show you from the the get-go of this process. All right. So the way that you create a query, all right, because you can see I got some stuff here, but we actually want to, okay, so what you do is you go to create, like we're going to create a query. Now, I always kind of joke is like, don't be lame, don't try to use some query wizard. Like that's nobody, especially if you're in the job industry, you're trying to get a job understanding relational database technology. Don't hurt yourself by trying to go through some query wizard. It's just don't do that, okay? Because employers really care that you know SQL. It's very in demand. All right, so I'm going to click. What we're going to do is we're going to go to query design. All right. So in this case, anything graphical, don't even deal with it. Would be my recommendation, because what I am teaching you is not to become, even though you could become an expert in Microsoft Access. That's not my goal though. My goal is to teach you, I'm using Microsoft Access like a tricycle. Like if I am trying to teach you how to ride a bike, I'm going to start you with something a little more simple. The thing though is, when we're dealing with SQL, I don't want you getting locked onto this visual kind of stuff, all right? So what I'm saying is, this thing pops up saying like, oh, some show table dot, like I don't even care about it. I'm going to close this down. This section here can kind of help you. It already kind of hurts you. It's kind of more annoying to deal with. This interface is called Query by Example, QBE. We're not going to use that. We're going to go to this section where if you look on your left-hand side, it says SQL. There's a couple different ways of actually just seeing the SQL, all right, or getting to this mode. Sorry, it just takes me a little bit talking. I had to drink a little more water. All right, so what you can do is you can kind of just click this down arrow and click on SQL view, because we're currently in supposed design view, but we want to see the SQL view. All right. Now, remember, we want to get every employee who has health plans. So oftentimes when you're trying to write a query, look at this is Microsoft's version of an ERD, an entity relationship diagram. Now to be clear, if you're a little confused in what I'm even saying, an entity is also called a table, okay? So an entity is a table. So like the employees table is also known as the employees entity. The benefits table is also known as the benefits entity. It's just a thing, all right? That's what it is. It's some object, it's something, all right? So this entity that we have, what we care about is, do employees have health plans? Now, where the health plan aspect is recorded is over here, under the benefits table, and it's connected to the employees table. So this entity is connected to this entity, and this connection is called a relationship. That's why it's called an entity relationship diagram. Okay? So what we need to do in this regard to figure out which employees have health plans is we need to join these tables in SQL code and then filter down where we only want to see those that actually have a health plan. If they don't, like, I'll give you an example. If I open up benefits and there's certain, like this employee here, they don't have a health plan. So in that case, we do not want to see employee ID 1003. Okay, does that make sense? That's the goal. We don't want to see this of the query that we're trying to build. All right. So with that in mind, I'm going to close this down. I'm going to go back over in this tab, this query setup, and I'm going to just start typing, and I'm going to explain the SQL query as we go through. So say we're interested, we want to know the employees, like we want to know the employee ID, their last name, their first name, and then over here if they have a health plan. Okay, that's basically the goal. That's what we want to see, and if they have a health plan. Okay, so with that being the case, we want to select only those rows. That's why I'm not doing select star. We don't want to see every single row. We only want to see some of these, or not row, I apologize. We only want to see, when we do select star, this is dealing with your columns. My apologies. That we only want to see certain columns. So in that regard, I'm going to type it like this. I'm going to start out, we want to see the employee ID, okay? But I have to write it, now with this database that I'm dealing with, this relationship is kind of interesting because it's referred to as a one-to-one relationship, and they both have this thing of emp underscore ID. Same thing with this one, emp underscore ID. So in our query, anytime there's two of these columns that are named exactly the same, like effectively one of these is serving as the foreign key, all right? We need to be explicit which one. It doesn't 100% matter, like in the type of join that it's called an inner join. It doesn't really matter, just kind of pick one. So this syntax, what this is talking about is this is the table name, okay, or the entity name, and then this dot thing is just separating like the column, okay. So this is table dot column. So in this case, the employee table, we want to get the employee ID column, all right. It would functionally work the same if we chose the benefits dot emp ID too. It doesn't really matter in this case, but I'm just doing it because we're talking about employee health plans. When we look at this code later, it tends to, you know, seem a little more consistent of what we're looking at, okay? So we want to know the employee ID. I'm going to do comma. I want to know their last name, so last underscore name, okay? Comma. We want to know their first name. And then we do want to see if they have a health plan. We just want to kind of double check that what information we have is also showing us this, okay? Now, I don't want to have this semicolon here yet, all right? For the time being, I'm just going to delete that. I'll add this back later just so we don't get confused. Now, I'm going to press enter. I'm going to go from, I want to get it from the employees table and the benefits table, all right? But we need to join it properly. So in this case, this table design is slightly, like I said, slightly interesting because the primary key in each of these tables is serving, like one of these is actually serving as the foreign key. That's not the most common design. You can see it here and there, but that's what's going on in this regard. So what I'm saying is these, and Access is even showing you of how it's connecting these lines together. It's showing you the primary key to foreign key relationship. Okay, so that's what we need to type in this regard. So that's why I'm going to say where, I'm going to logically connect these things together. Where the employees table.emp ID is equal to the benefits.emp ID column. Okay, but we don't want to stop there because that's getting all of the data. We don't want to see all of the data. We want to see only the employees that have health plans. So that's where I'm just going to manually just go 1, 2, 3, 4. You don't have to do this. This is my preferred. This is really common though in industry. And so we want to have another condition here. We want to be like, and we only want to see people who have health plans. So in Microsoft Access, the way you could write this is like this. And health plan is equal to true. This is a value, meaning like they actually, like if you looked at the check mark thing that you saw earlier, that was actually checked, okay? So let's give this a shot. I'm going to, you could do this you could go up to design and then click on run. And let's see, oh, I have a typo. So if you ever run into this situation, this little dialogue thing pops up and it's like, what? what this is basically saying is you probably have a typo somewhere. It doesn't know what you typed in there. That's okay. This is, why it's good to make a video, so that when you run into this, which I'm sure a lot of you are going to run into something like this is letting you know, like, you got some bad SQL syntax somewhere, okay, of what you're trying to do. Because we don't want some custom prompt thing, input, whatever. So I'm going to be like, wait a minute. Did something wrong, because it says employee.empid. So this is my tip off of, like, when I wrote it up here, it should say employees, because that was the name of my table. So I'm going to fix that now. So I'm going to click cancel, because I don't want to try running some query. I'm going to fix this. I'm going to put the S here. Okay, so I put the S here, employees.empid. Hopefully the rest of my syntax is good. Oh wait, this should say benefits. Haha. See? Even the pros make mistakes here and there. That's part of the fun, though, right? Okay, now let's try running this query. Are you ready? And go. Sweet. Now, notice how, remember, like if we pulled up, I'm going to manually click over here, the benefits table. Employee ID 1003 did not have a health plan. Okay, I'm going to close this down. Over here, we do not see employee 1003. It jumps. It goes from 1001, 1002 to 1005. All right. So in this case, what I am showing you is not just some visual, like, oh, cool, look at my SQL. No, I am actually practicing what I preach. Is you want to double check that your SQL query seems to be working correct. You don't want to base your information on, well, bad information. Okay, and you can see all of these. This is how Microsoft Access does this. This is basically a Boolean value where it's like true or false, or 1 and 0 and such. Access is kind of goofy. They like this thing of -1 and 0 to be true and false, or they actually call this column a yes/no data type. It's true or false, basically, is what I'm saying, right? So that's why it's, when you write the SQL code, I just like true and false. It's just more consistent. So yeah, if we basically, now look at this. This is usable information. We've just asked which employees have health plans. This is what it told us this. Okay. Now, the other thing too is, say if I like X this out, it's gonna be like, wait. Do you want to save this query? Like, do you think you might want to use this later? Yeah, you might want to, right? Like, say a company that is running, some company, right? And their employees, they want to know who has health plans. So it's often preferred to actually just save useful queries. So let me cancel this. I don't want to close this yet. We're going to save this query. So what I'm going to do is I'm going to this is my process. I'm going to right click on save. I would recommend choosing something way more memorable than query 1, because what is that, right? What I'm going to do, you can name yours different. I don't know if you can see this little font that I'm looking at. Is I'm just going to say MT, meaning like multi-table, just because that's how I'm making this video, right? MT1, this is the first query I'm showing you, so that says MT1. I'm just ordering things on the left-hand side, just keeping it in alphabetical order. MT1, I'm going to say employees with health plans. Notice how I am separating everything by these underscore characters. Microsoft Access will let you type with just, say, spaces. Do not do that. That is a horrible habit to get into, all right? Like, if you're using a more serious database system such as MySQL or Oracle or whatever, people will hate you in those environments. Use underscore characters, all right? So, with that said, this is what I'm going to call my query, because I can remember what this is about. I'm going to click OK. And that's that. Now this has been renamed to what I just typed. Okay. So then we can even see it over here now. It's in alphabetical. I got a bunch of stuff going on. But this is the thing that I just saved. All right. So we could close this down, for instance. And then if we just double click on this thing, because this is now a query, we could double click and boom, it reruns this query. Now this is useful. A query is not just like a static spreadsheet thing. This is actually like if our data changes, like say Kate Navarro next year doesn't sign up for the health plan. Well, then if we double click this thing, like, boop, we will not see Kate Navarro anymore when we run that query. So it's a very live type response type situation. Okay. Now let's move on to something just make sure you're familiar with SQL syntax and such. What if we're just interested in knowing which employees don't have health plans? Well, we're not actually changing all that much now, okay? We just need to basically change one little thing from what we just created, and that's it. So I'm going to do that. But instead of rewriting everything all over again, what we can do is I'm going to right click here. I'm going to click on copy. So I'm going to copy this query and then say, I'll just right click on top of it again. I'll click paste just because it's in this area. We got to rename it to something else. Instead of starting with copy of, I'm going to call this multi-table like query 2 basically. And in this case, I'm just changing it so it's employees without health plans. Okay, so I'm going to click OK. So now this thing showed up here. This is what just popped up. I'm going to close, say, this one down. That was the first query. Now, if we double click this, it did not magically figure out what we wanted because that's how we named it. Okay, just to be clear. What we need to do is we need to change the SQL. All right. So again, we're going to go back into SQL view. So I'm going to go over here, click the down arrow. I'm going to go to SQL view. Okay. Now this is what we see so far. So in this case, we just want to change it so instead of that the employee has a health plan, that they don't have a health plan. So the way you would say that in SQL, in Microsoft Access specifically in this regard, is you could write it like this. Like instead of saying and health plan equals true, we're going to say and health plan equals false. Okay? So if I save this, and then you can either click run up here, or I get into this habit because I get a bunch of these tabs that show up all over the place here, that I'll just right click, and then what you can do is you can go down to datasheet view. It's the exact same thing as clicking run. Datasheet view, or run, right? That here, look at employee ID 1003. That is, as I highlighted before, this employee did not have a health plan. That's why it is not checked. So our query is now working. Okay? Huh. How do you feel so far? It's not too bad, right? Okay, now let's move on to some more queries. I'm just going to kind of keep going through this to kind of drill in SQL syntax so you can see how this plays in when you're dealing with, more database tables, which is common in a relational database system. All right. So what if we wanted, here, I'll close this down. If we're looking at our benefits table and we see all this stuff going on, and say there's some human resource question of I see we have it says here 31 employees, and they have different life insurance values and such. Like some of them have 100K, some have 200,000, so on and so forth. Maybe they're just curious for some reason. They're doing data analysis or whatever, and they want to know, well, which employees basically don't have any life insurance, or you could say I'll put it as 0K later in a sort of sense, or up to 100K. So we only want to see employees that have from 0 to 100,000 life insurance. Okay, that's all we want to see. So how you do that is I'm going to go to this. I'm going to go create query design. We don't want the wizard. We're going to ignore this graphical user interface, the GUI. We don't care about this. X out of that. I do not care about this query by example stuff, QBE. And what we could do is, down arrow, go to SQL view, or you can actually just click on the letters up here and just go SQL. All right. So the way you'd write the syntax is, for instance, so it's again between the employees and the benefits table because that has life insurance. Okay. So with that being the case, I'm going to get rid of the semicolon for time being, going to type that in there. So I'm going to say I want to see the employee's EMP ID, their employee ID number. I want to know their last name, their first name, and what they have for life insurance. Okay, so I'm getting it from the employees and the benefits tables where they logically connect. Employees.emp ID is equal to benefits.emp ID. 2, 3, 4, and we only want to see, again, if they have life insurance between 0, like they don't have any life insurance, and 100,000. So I'm just going to put 100, 1, 2, 3, and then I'm going to put my semicolon there. All right. Like, kind of pause on the syntax for a bit. Hopefully this works. I'm going to try running it. I'm going to go, design, run. Seems like our SQL is making sense. We're only seeing these employees with those values. We don't see any higher life insurance values. Okay. So that's what I'm just double and triple checking that the information we got seems legitimate. Okay. Sounds good. So I'm going to save this query. Go through here. I'll just call this multi-table 3 employees with life insurance. I'll say 0K. You could say 0, whatever. To 100K. I just figured that monetary 0K stands out to me better. I'm going to click OK. That sounds good. This now shows up over here. Boom, it's really long, blah, 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 blah. I could close this down. I could rerun this thing. Boom, we now have a cool little multi-table query. Life insurance, 0K to 100K. Great. All right, another example. Let's see here. What if we're interested? Let's change it up. If we want to know, has an employee ever been absent, basically? Like, were they ever out sick? Did they have to go to jury duty? Like, look, I'm going to go to absences. Some people were out sick, bereavement leave, vacation, okay? And it says which employee took what day off and so forth. Well, I'm closing the benefits table. Say that we just want to know who has ever taken a day off. All right, they're not on a nasty list. It's just more of for accountability purposes or whatever. All right, so let me show you. What I'm going to do is there's actually going to be 2 different queries I'm going to show you. The first one, you're going to see why I'll do a second query, but I want to just highlight one aspect that confuses people when they're trying to learn SQL, like why you would use certain features. This is where this comes in. All right, you're gonna see what I'm talking about in just a moment. Okay, so with that being the case, I'm gonna create this query. I'm gonna go create query design. I don't care about graphical stuff. Also, another area to get you used to. You can even use your mouse over here. Little tiny little SQL button thing. I'm gonna click that. Boom. There's another way to get to this SQL zone. All right. So here we go. What we're going to do is I'm going to do select. I want to know their last name, their first name, and their employee ID. And I put the employee ID over there because it's like maybe we care about sorting by last name. All right, that's why I didn't put it first. And then we want to get it, in this case, from the absences table and the employees table, right? Not the benefits. We're not including benefits now. Now, the thing is, you want to look at your ERD. That's why I'm a huge fan of these entity relationship diagrams. How do they logically connect? Now, in this case, this is a more traditional looking connection, all right, a more traditional relationship. Is that the employees table has a primary key, that's what the little key symbol is, of emp ID. And on the absences side, what it's saying is they have this is a foreign key. There's no key little symbol. It's connected here. So I know that this is the foreign key in this regard. All right. So what this relationship is saying is that an employee could have like 0 or many absences. Like, you know, maybe they never took a day off, or they could take like 2 or 3 or 4 days off, or whatever they're allowed. Okay. So that's why they might have multiple rows showing up on this side. So that's why in this case, this is referred to as a one-to-many relationship. Okay? But the thing is, every absence over here, what they're doing here is like absence ID 1. Okay? It's like the first employee that has ever taken a day off or something like that. In this case, employee ID 1065 took the first day off January 2nd, 2019 for a sick day. And then they were still sick the next day. So that's why this other row showed up. And then somebody else was sick later on, okay, on January 5th, and so forth. This is each row here should actually connect with an employee, okay? So in that case, this is way, again, we're going to kind of merge our data. We're going to join our data together to figure out, the original question is, who has like ever taken a day off, okay? So I've already started the process of creating the query, okay? We want to know their last name, first name, employees, here I go again, employees.empid, from absences, comma, employees, and then in this regard, these two tables connect here, again, to remind you. We have employees.empid, which connects over here, the absences.empid. We don't want to go to absence ID. We want to go to emp ID. That's where these two tables connect properly. That's when they make sense, okay, where the data is the same. All right? So over here, that's why I'm going to write where absences.emp ID is equal to employees.emp ID. Again, I'm just doing a left to right thing. I'm looking at my relationship. It doesn't really matter if you flip-flop these around. It's just when I look at my diagram, this is on the left-hand side, connects to the right-hand side. That's why I'm writing my syntax in this regard, okay? Then, say we want to also order it. We want to like sort it. Order by last name. I do this because it'll help jump out more of why we probably want to create another query later if we want to know who has ever been absent, because watch what happens. I'm going to go to design, or we can, again, right click, go to datasheet view. So what this is saying is, and we can even double check this, say absences, Peter Chovanec, employee ID 1023 has been absent twice. Okay, 1023 shows up twice over here, and I don't think 1023 ever shows up anymore. No, they shouldn't. Okay, so I'm just scrolling. I'm looking actually at the absences table, and I'm double checking my query. Okay, I want to make sure that my information is good information here. All right. Then we have like Edgar Codd. He's taken a couple days off. Stacy Fry has only taken 1 day off. Okay. But not every employee has ever taken a day off. All right. These are the only people who have taken days off. But notice here, it's showing up that Peter Chovanec lists twice. So it looks redundant, right? It's actually not, again, because like as I was showing you, it's actually like accounting for, say, Peter Chovanec, employee ID is 1023. Well, he shows up twice over here. So that's why in this query it's showing up twice. But say we were asked by our manager to like print out this report, print out who has ever taken a day off. And we print out this report and they're like, what are you doing? Why am I seeing Peter Chovanec twice? This is really confusing. And they get mad at you. Okay. So I'm going to show you in just a moment another way of creating this query. But let me save this for now. I'm going to say save. I'll just call this multi-table for employees that have been absent. Okay. Sounds good. Okay, that shows up here. Now, we're going to change this query slightly. I'm going to just close this down. What we're going to do is I'm just going to create another query. I'm just going to copy this one. I'm going to base it off this kind of template. Copy this thing, and then just right click again, this area, paste. We're going to rename it. I don't want it saying copy of because then it's going to mess up the ordering over here. I'll call this number 5, like this is my 5th query thing. And I'm going to put on the very tail end here, you're going to see why. I'm going to put an all uppercase distinct. Okay, so highlighting number 5. I ran the query. That we got to fix a query now. We're going to change it up. Right click, SQL view. The one little tiny aspect we want to change is we don't want to see the same employee listed multiple times, like twice or 3 times in the query. So with that, we want to do this thing of select distinct. Okay, see this, distinct. We want to distinctly see one thing. Okay, so you now watch. I'll just run the query. Run. Boom. It's the same thing. It's just now if it sees redundant looking rows, it will just ignore it and just only show us one value of that row. Okay. So now to say address your boss's question is, who has ever taken a day off? This is the better way to write it for a manager's perspective. Like they don't want to see the same person twice or whatever. That's going to confuse them. Okay. You want to distinctly see each row value. In this regard, distinct is a way to kind of filter your output, okay? And that's why you might want to use that distinct clause, okay? So, yeah, that's it. That's all there is to this query. I'm going to save the. If I exit, it's going to be like, hey, you want to save this thing? It's like, yes, I do want to change the design of the query because I changed it. I changed the design of the query. So I'm going to say yes. So there we go. Okay, moving on. Now, what I'm going to introduce you to is this idea of an outer join, okay? Because what I've been presenting so far is dealing with inner joins. Like if I go to my thing here, what I'm saying is when we connect these two queries together, we want to see rows that actually like exist on both of these tables, all right? An outer join, though, can be very powerful because, like, say, for instance, look at our absences table here. It's showing us who has taken a day off, okay? But then maybe, wait a minute, who has never taken a day off, right? In this case, this table design that we have is not actually capturing that information. We don't know, unless they show up here. The only reason they would show up in this table because they would, this is the primary key, this absence ID thing, like 1, 2, 3, 4, 5, like the 5th absence ever taken was this person for jury duty, okay? But if somebody who's never taken a day off, they would not be in this table that we have, you know, put into our system. So how would we then capture that? Well, actually, what we would do is we need to find an outer join. We want to join these two tables and then figure out basically which ones don't actually show up in this table. Okay? So what I'm going to do to get to that aspect, just like I just did, I'm going to do this kind of 2-part query thing. All right? So the first part, you're going to visually see what is going on in the background. Okay? Later in time, when you're just like doing this as a professional, you wouldn't do this first part necessarily. This is like more of a temporary step. You'd eventually get to the like part 2 thing. Okay, that's what you would really do. So with that in mind, that's what we're going to do. We're going to figure out which employees have never been absent. Okay, so same thing. I'm going to go to Create, Query Design. I don't care about this graphical stuff. SQL View. Okay. Now, here we go. We want to do select, last name, first name, and then employees.emp ID. And I'm going to just show you this absence ID here. Okay, we'll eventually get rid of that in a later process. Now we want to do this. We want to get it from between the absences and employees tables. Okay, so what we do is I'll do this capital from absences. In this case, what I'm doing here, I'm gonna write this thing where it's like right outer join. The reason I'm writing it like that is because the way the first table that I'm listing is absences, so it's like it doesn't have to do with this ERD. Okay, just to be clear, it's actually how I'm writing my SQL syntax. So the first table that I'm going to list here is absences. Okay, just because again I'm just making it basically be the same as my ERD. But this will be on my left-hand portion of how I write the code. Okay, so but we want to see basically employees that do not show up here. Like everybody here will it's like a Venn diagram where it's like we only want to see those that do not show up here. Okay, so that's why I'm going to write absences right outer join employees. Now, before I move on, what I will say is Microsoft Access, they kind of annoy me, is that if you save this query, close it down, open it up later, it's going to actually remove this outer thing. It drives me nuts, actually. It's like, just stop messing with my SQL there, Microsoft Access. But anyways, just be clear. I'm writing this code like this because this is the best way to write it when you're dealing with other systems and stuff. All right, and Access should change their stuff, basically. So anyways, so we want to do what I'm doing a join here. Instead of it like you saw the syntax before where I did like absences comma employees, this is the other style of writing a join. Okay, and in this regard, this is why you would want to do it, because you need, for an outer join, we want to get stuff that is not included in another table. This is how you have to write the syntax. Okay, so that's why it says from absences, this table, we're going to join it to the employees in an outer join type process. You're going to see more proof in the pudding than what I'm talking about here. And then 1, 2, 3, 4 on. This is like that join condition. This is where this thing shows up. These tables, absences, are connected properly here. Absences.empid is equal to employees.empid. And then we're going to order, like we did kind of before, we're going to order by the last name. Okay, let me see. I'm going to try running this query. Right click, say datasheet view. Yes. So look at this. Look at what's going on. This is where it looks a little more interesting. Is it, as you saw before, Peter Chovanec, he showed up twice, right? So he had absence IDs, and it says 4 and 3. So he was here, third and fourth row, or 4 and 3, was Peter Chovanec. Okay, that's why he shows up here, and we see the absence ID, because the query. Let me go back to the query. The query. I want to see the absence ID. I did this so you could see what's going on. All right, with this outer join thing. Now, if I go back though, I'm going to go back to the datasheet view. Notice that say Melissa Alvarado. She has never taken a day off. Okay, that's why this thing is blank. Another way you would say this in database terminology is it is actually null, like N-U-L-L. Okay, this is a null value. It's a nothing value. She has never taken a day off. That's why it's blank here. Okay, so as you can see, and you can scroll down, and you basically get a report of every employee here. And if they show up multiple times, it's like telling you what their absence ID was and so on and so forth. But the original goal of our SQL is we only want to see basically the people that have never taken a day. We only see these people that have nothing, a null value here. Okay, that's why I'm going to go into this part 2 thing. Okay, let me save this query. I'll go back to the SQL so you can see it. Okay, you can pause it, look at it, and so forth. I'm going to save it as I'm just going to call it like this. It'll be like MT6 part 1 outer join. I'm being very kind of verbose. Employees, very wordy, that have never been absent. Okay, sounds good. Close this down. What we're going to do, I'm going to copy this, the one I just created, paste it. Now I'm going to change it to basically just be, get rid of this copy of part 2. Click OK. I'll open up part 2 now. I'm going to change this. We don't want to see absence ID anymore, and so I'm going to get rid of this. I don't want to see absence ID. And as you notice, it got rid of access. This is what I'm talking about. Access got rid of my outer join thing. It drives me nuts. And then it like rearranges my syntax here. So I then change it, fight with access all the time, and it drives me nuts. Anyhow, so I got rid of that absence ID column because we don't want to see that. We only want, if we're presenting a report to our manager, you don't want a bunch of blank values there. That's weird. So the other thing though is that the syntax is all pretty much the same in the most part. Okay, we just want another condition here. Okay, so what I'm going to do is before I type order by, okay, we'll still have that. I'm going to type where the absence ID is null. Like it is blank, it is nothing. Okay, let me see if this works. I'm going to run this thing. There we go. We have Melissa Alvarado, but we don't see like Peter Chovanec. You see, I'm double checking to make sure that this makes sense. So, there we go. We have now this multi-table query where we now know who has never taken a day off, who has never been absent. And here is the code again. Okay. And then I'll save this. Right click save. Okay, the last thing that I want to show you is what I've been dealing with so far is between basically 2 tables. All right. But the thing is that the multi-table query, you can do with 3 tables, 4 tables, 50 tables if you want to get nuts. All right. Try not to. You don't have to. Anyhow, what I'm going to show you is a 3-table multi-table query. All right. What we're going to do is we want to figure out which employees have dental plans that are only from the departments of basically the I think it's the accounting department. Let me double check. Departments here. Yeah, accounting and IT. All right. And we actually want to see accounting and like information technology services rather than just like department A and IT. Okay. We want it to be like very obvious of where these people come from. Okay. So I'm going to close this down. Here we go. And what we're going to do is we need to actually combine between the, say, the benefits to the employees table and then to the departments. So the way I'm going to write my syntax is going to look like this. I'm going to start with benefits, employees to departments, because what I'm doing, this is me. You can do things differently. I'm starting with like top to bottom. I'm just starting over here, and this little line is connecting over here. So that's why I'm going to list this table first, then this table, and then this table. Okay, I'm just going bing, bum, boom, over here. All right. Now, let me see. I can close this kind of table down. I don't need that anymore. So I'm going to create query design. I don't care about graphical stuff. I don't care about query by example nonsense. Here we go. Here we are. So we want to select these columns, the employees dot emp ID. Actually, I'm going to get rid of. Not double click. Just click this thing so I can. I need some more room here because it gets kind of wordy with everything. All right. So employees dot emp ID, comma, last name. I want to see the first name column. I want to see if they have a dental plan, and I want to know if what department name it is. Department is the column name for that. So then I'm getting it from. Remember how I said we're starting with benefits, comma, employees, comma, departments. Right, so there's 3 tables: benefits, employees, and departments. And now we have to have the join conditions. Those join conditions still make sense. We need to go from benefits to employees and employees to benefits. The way that works is we follow our entity relationship diagram. It's a map telling us how to do this. So we connect from the employee ID column from the benefits table to the employee ID column to the employees table. But when we go from the employees table to the departments, it actually has a department ID which connects over to here. All right. So you're going to see this in code now, SQL code. So we're going to go where benefits.emp ID is equal to the employees.emp ID, and we now also need to say employees again, employees.department ID now though, because we're connecting employees to department, is equal to the column I just mentioned, departments.department ID. And let's get funky here. Check this out. And boom, we got a parenthesis situation. We want to know like only from 2 departments. The accounting department. We want to see employees with health plan or employees with dental plans only from departments like the accounting department and the IT department. All right. So the way that we do this is we have this parenthesis situation, employees dot department ID is equal to A, because that's the, you can check back, that's the accounting department. Or, okay, we want either one, accounting or IT, so we then say employees dot department ID is equal to IT, and I'm using these single quote characters. And then I close out my parenthesis, and then I put a semicolon here. I'm just double checking my syntax. Hopefully, I think it looks all right. Let's try running this code. So I'm going to go to, say, design, run. So look, we're only seeing the accounting department, but we don't just see A. We want to know the name of the accounting. We want to, like you print this out for managers. You don't want to see department A. Like, what is that? Accounting department. Okay. And it's showing us these employees. So every employee from the accounting department. And we just want to know if they have a dental plan. It doesn't matter if they have it or not. We just want to know, like, from these 2 departments, what's the deal? Who has what? Okay. Who actually has a dental plan? Who doesn't? They want to know. That's for some reason they need to know this report. Okay. So in the IT department, Edgar Rowe or Ken Thompson and stuff like that, they do have dental plans, but then like Wesley Koenig, can't say that, and yeah. So this, look at this pretty cool little query. Like, it seems simplistic if we just run this. If this is all that we're looking at, but you don't realize like all the effort, all the SQL syntax you had to come up with, and the understanding of your database to connect it all together to come up with one little report. you see how that it gets a little more sophisticated. And then, let me see, I'll just save this because I get in the habit of saving everything. 7, I'll just say 3 tables. I'll just say shorthand emps with, like, employees with dental plans from departments A or IT. Very long and wordy, but it's descriptive. You know what I'm saying? Anyhow, yeah. I guess it kind of fit all in one screen. Well, except for this part. But that is, go back to data view. So this is the what we wanted. Right, and I just saved that here. I will minimize this again. So one more time, here is the code to make all of this happen. So the main idea is the basic SQL that you learn, which again I plan to upload in another video, is you can combine it into very powerful ways to understand a lot more details about your database. The information that might be kind of hidden unless you had, you don't want to like manually try to figure out who has a dental plan or whatever, or who's from what department. Like it, could be tedious. So that's why an SQL syntax, especially if you use this kind of report all the time, can be very useful. I think that actually concludes, for the most part, everything that I wanted to touch on. So hopefully this makes sense. In what I plan to do over time for those that might be interested is actually say post this kind of data set so you can work with it. So I apologize if you're viewing this video and you don't get to experience this firsthand right now, but I do plan to upload this, and so pay attention to that. I'll point down in the YouTube summary, the description of, I'll eventually update those details for those that are interested. But yeah, I hope you learned a lot, and now you have a better understanding of what SQL multi-table queries are. Okay, thank you so much for watching, and I guess you'll hear from me later on. Okay, have a good night.